Hello everyone, in this video I'm going to discuss the example for limits and continuity. Given we have the function 2 multiply with the modulus of x over x plus with the 5x. So here we have the modulus of x. Kindly define the situation. So we have x greater equals to 0, negative x less than 0. So that is the definition. We write the situation in a real number line. So we have negative x for x less than 0, and we have the x for the situation x greater equals to 0. Compute the limit when x approaching 0 from the left. Compute the limit when x approaching 0 from the right. So we have the function fx. So refers to the situation 0 from the left. So here we have 2 multiply. So when they mention 0 from the left, we are focusing on this side. Then we have negative x over the x plus with the 5x. Limit when x approaching 0 from the left, and we notice that we have negative 2 plus with the 5x. If we substitute the value, and we will have negative 2, meaning that the value of y approaching negative 2 when the x approaching 0 from the left. Focus on the right. So limit when x approaching 0 from the right, we have the function 2 multiply with the x because towards the right over x plus with the 5x. Rewrite the situation, limit when x approaching 0 from the right. So we have 2 plus with the 5x. If we substitute the value of y will be approaching 2. Limit when x approaching 0 from the left for the function fx is not equals to limit when x approaching 0 from the right for the function fx. Then we can say limit when x approaching 0 for the function fx does not exist. So next, is the f continuous at x is equals to 0? Give your reason. Condition number 1, f0. So for this case, kindly refers to the definition x greater and equals to 0. So meaning that when x is equals to 0, we have to focus on this part. Then we have 2 multiply with the x over the x plus with the 5x. Rewrite the situation. So f0 is equals to 2 plus with the 5x. Then if we substitute 0, so f0 is equals to 2. That is the first condition. For the second condition, limit when x approaching 0 for the function fx does not exist. Then from here we can state that the conclusion, so fx is not continuous and x is equals to 0. Kindly refers to b. The continuous function g is defined by where we have the gx. So kindly illustrate the situation in a real number line. So here we have the value a. So x less than a. So here we have the set 5 minus x. X greater and equals to a. So here we have 3x minus 1. So the question said the continuous function g is defined by the situation given in the gx. Find the value of a. Since they already mentioned that g is continuous, so meaning that the limits from the left and from the right are the same. So here we have the limit when x approaching a from the left. The function, we have the square root 5 minus x equals to limit when x approaching a from the right. For the function, we have 3x minus 1. Kindly substitute the value. So here we have the square root 5 minus a. Here we have 3a minus 1. So my suggestion would be square both sides in order to eliminate the set. Then we expand, we have 5 minus a equals to 9a squared minus 6a plus with the 1. Rearrange the situation, we have 9a squared minus 5a minus 4 equals to 0. Kindly factorize the situation. So we have 9a plus with the 4 multiply with a minus 1 equals to 0. So a will be equals to negative 4 over 9. A will be equals to 1. Next, we're going to test the value. Does the gx continuous at a, which is equals to negative 4 over 9? So condition number 1, g bracket, we have negative 4 over 9. As it refers to the real number line, if the a is negative 4 over 9, then we have to substitute the situation. Here we have 3 multiplied with negative 4 over 9 and then minus 1. So by referring to the calculator, then we have negative 12 over 9 minus 1. So for the value, g bracket negative 4 over 9, which is equals to negative 7 over 3. So define. Second step, limit when x approaching negative 4 over 9 from the left. Limit when x approaching negative 4 over 9 from the right. The function will be square root of 5 minus x. The function will be 3x minus 1. So kindly substitute the value. So if we substitute, we will have square root of 5 plus with 4 over 9. Then we will have square root of 49 over 9. So limit when x approaching negative 4 over 9 from the left for the function gx, the value of y will be approaching 7 over 3. Move on with the next part. We have to substitute the value 3 multiplied with negative 4 over 9 minus with the 1. So rewrite the situation. So we will have negative 12 over 9 minus 1. So limit when x approaching negative 4 over 9 from the right for the function gx, and we have the situation negative 7 over 3. So limit when x approaching negative 4 over 9 from the left for the function gx is not the same for the limit when x approaching negative 4 over 9 from the right for the function gx. Then we can say limit when x approaching negative 4 over 9 for the function gx does not exist. Then for the conclusion, gx is discontinuous at a is equals to negative 4 over 9. So that is the first part, negative 4 over 9. Next, does the gx continuous at a equal to 1? So meaning start, we have to substitute, this one become 1. So condition number 1, g1. We have to substitute 3 multiplied with the 1 minus 1. So the value of g1 is equals to 2. Second condition, limit when x approaching 1 from the left. Limit when x approaching 1 from the right for the function square root of 5 minus x, the value of y approaching 2. For the function 3x minus 1, the value of y approaching 2 as well. So limit when x approaching 1 from the left for the function gx is the same for the limit when x approaching 1 from the right for the function gx. So limit when x approaching 1 for the function gx, the value of y approaching 2, and we can say the limit exists. Step number 3, g1 is equals to limit when x approaching 1 for the function gx. So the value are the same. So conclusion, gx is continuous at a is equals to 1. So we can say here valid when a is equals to 1.
If you are new here, kindly consider subscribing to this channel and share this video to your friend. Thank you so much for watching this video. Bye.